In this video, we're going to go over how to solve quadratic equations that are specifically designed to be solved using the square root property. Before we get into it, there's a couple things I want to review, starting with the perfect square numbers. What do I mean by the perfect square numbers? I mean, what is 1 squared? What is 2 squared? What is 3 squared? And what is 4 squared, right? Do this all the way to 15. Pause the video. Try to go all the way to 15. I'm just going to write them out here. Not much explanation. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 25. 36. 49. 64. 81. 100, right? That's 10 squared. 121, that's 11 squared. 12 squared is 144. Some people haven't memorized the 12 squared. 13 squared is 169, and 14 squared is 196. So a little pattern there. And then 15 squared is 225, right? So, ideally you have these numbers memorized, but I know that's unrealistic. At least be able to recognize these, be familiar with these. These numbers are going to make your life so much easier when it comes to solving these equations. But first, let's simplify radicals, which is where these perfect square numbers are going to come in. So what you'll notice here, I'm going to take the square root of 28, but 28 is not on this list. It is not a perfect square number. So we can't square root it evenly, but we can break it apart. Now, some of you may have been taught to use a factor tree, right? 28 is 7 times 4, and 4 you could break that into 2 and 2, and you could simplify it that way, yes. That is foolproof. It will always work. However, I want to teach you a more efficient way, but it requires that you're comfortable with the perfect square numbers. So 28, that is 4 times 7. And why do we like 4? Well, we like 4 because it is a perfect square number. So I can split this up into root 4 times root 7, and root 4 is 2. The 7 cannot be simplified. So again, you're asking yourself here with this 98, you're going to ask yourself, 98 is not a perfect square number, but which perfect square number is 98 divisible by? And that's going to be 49. 98 is 49 times 2. We can split this up into root 49 times root 2, and root 49 is 7. 7 root 2. Here we have root 108. 108 is not a perfect square number, but ask yourself, right? Pause the video and try to figure this out. Which perfect square number is 108 divisible by? Now, I'm going to slightly ruin the surprise. 108 is divisible by 4. However, go bigger. Find the biggest perfect square number that 108 is divisible by and pull it out. And that's going to be 36. 108 is 36 times 3. 36 is a perfect square number. Split these up, and we get 6 root 3. So, good. You can avoid a factor tree if you're able to pull out perfect square numbers. It is more efficient than the factor tree. All right, before we do the next row, let's remind ourselves here that the square root of -1 is I. It's okay if you don't understand that, just roll with it. Every time we get to a root -1, we're going to replace it with an I. So down here, we're at -175. We're going to break off the -1, and then 175. Okay, 175 is divisible by which perfect square number? That's going to be 25. 25 times 7. Right, 175 is 25 times 7. We can break this apart. I'm going to rearrange the order here a little bit, and that's okay. You can do that. All right, the square root of 25 is 5. The square root of -1 is I. And then we cannot simplify root 7, so it stays root 7. Thus, root -175 simplifies to 5i root 7. Here we have negative root 45. Again, take a minute, think about it. 45 is divisible by which perfect square number? We're going to go 9 and 5. 9 being the perfect square number. Break apart the pieces. Root 9 is 3. Root -1 is I. And root 5 is, well, root 5. Can't simplify that piece. Here we go. Peel off the negative. 162 is 81 times 2. We like 81. 81's a perfect square number. Break apart the pieces. Give you 9i root 2. If you like the factor tree, that's fine. You can do the factor tree. But if you're cool using perfect square numbers, it'll get you to the answer faster. This idea, everything we're doing still applies when you're dealing with fractions. So here, this is the same thing as root 17 over root 25. Oh, this is an easy one. 17 can't be simplified. Root 25 is 5, right? 25 is a perfect square number, so we didn't have to go fish anything out there. 17 is a prime number. It can't be broken down, so just leave it as root 17. Here we go. We have -18 on the top. So split this up. Split this up. Root -18 on the top. Root 49 on the bottom. Now, root 49, that's a clean one. That is 7. All right, no tricks there. But we do want to simplify the root -18. So split this up. All right, think which perfect square number goes in to 18. And that'll be 9. 9 goes into 18 twice, so 9 times 2. I'm going to start skipping steps because we've done this a lot now. Square root of 9 is 3. Square root of -1 is I. Root 2 over 7. That right there would be the answer. Last one, here we go. We got root -121. What's the square root of 121, right? That's a perfect square number. It's 11. Because it's negative, it will become 11i. And then we have to simplify this root 150 in the bottom. So again, think what perfect square number goes in to 150. And that's going to be 25. It goes in 5 times. So this equals 11i over square root of 25 is 5, and the additional 5 stays. Now, throwing a little extra thing right here, rationalize the denominator. We need to multiply the numerator and the denominator by root 5. Again, it's a matter of preference. Maybe something I'm not as aware of is why we don't like square roots in the denominator. Okay, fine. We put the noun before the verb. We don't like square roots in the denominator. We can get rid of it by multiplying the top and the bottom by root 5. So this would simplify to 11i. Let's fix that. 11i root 5 over 5 times root 5 squared, which is 11i root 5 over 25. So not a big deal if you don't see all those pieces. You might have to pause and think about it, right? Root 5 squared is 5 times 5 gives you 25. So that would be the answer for that one. Okay, now let's get to the point of the lesson. The square root property. Here's the square root property. This is it right here. If x squared equals a, then x equals plus or minus root a. These equations are unlike linear equations in the amount of solutions they will have, right? Linear equations, what you're most used to, I would imagine, have one solution. However, these quadratics usually are going to have two solutions. It's possible that they only have one, but most of the time they're going to have two solutions, and those two solutions are going to be marked by a positive and a negative, right? So let's see why this is the way it is before we start using it. What is 3 squared, right? 3 squared, let's just be thorough here. That's 3 times 3, and that is 9. Here, evaluate negative 3 squared. Now, be careful. The negative 3 here is in parentheses, which means we need to multiply negative 3 by itself, by negative 3. That's 2 negatives, right? So the important part here is that a negative times a negative is a positive. So this is also 9. 3 squared is 9. Negative 3 squared with parentheses is 9. So if I asked you, hey, I'm thinking of a number that if I square it, I get 9. What are the numbers that I could be thinking about, right? There are 2 numbers I could be thinking about, plus and minus 3. So if you're trying to solve the equation x squared equals 9, you have to realize that one of the solutions is positive 3, but negative 3 is also a possible solution. You must have both, plus or minus 3. Whenever you square root both sides, I should have put a square root here. Whenever you square root both sides, you're going to put a plus or minus, and that is the square root property. Okay, let's put it to work. So x squared equals 16. How do we get rid of a square? We square root, and whenever you square root, by the property, we do plus or minus. Square root of 16 is 4, so plus or minus 4. And that's it there. That's all you got to do there. That's one step. Here we have x squared minus 36 equals 0. First thing I'm going to do is add 36 to both sides, plus 36, plus 36. And I have x squared equals 36. And then at this point, you will take the square root of both sides, square root, property, square root property, plus or minus. So x equals plus or minus 6. Now, even though we're writing this as a single expression, realize that these are 2 solutions. There are 2 solutions here. When I write x equals plus or minus 6, we could also write the first solution is negative 6 and the second solution is 6. But, that's a lot of writing, so you can just leave it like that. Here, first step, divide both sides by 3. And we have x squared equals 75 divided by 3 is 25. Square root both sides. Square root property says plus or minus. Thus, x equals plus or minus 5. The top row. In the top row, all the roots were whole. We only had to take the square root of perfect square numbers. It's not going to be like that anymore. So now this is where that simplifying radicals is going to come in handy. Square root both sides. Square root property says plus or minus. So x equals plus or minus root 20. Now, 20 is not a perfect square number. However, we can simplify it. What perfect square number goes into 20? And that's going to be 4. It goes into 20 5 times. Square root of 4 is 2. The 5 stays underneath the root, and your answer is plus or minus 2 root 5. Here, our first step is to add 10 to both sides. Add 10, and we have x squared equals 63. To get rid of a square, we square root both sides, square root plus or minus. X equals plus or minus root 63. Now, 63 again is not a perfect square number. However, it is divisible by a perfect square number. Which is that? That'll be 9. And then 9 times 7 is 63. Square root of 9 is 3. The 7 stays. That's the answer. First step, divide by 5. We have x squared equals 80. Square root, plus or minus. X equals plus or minus root 80. All right, which perfect square number goes in to 80? And that's going to be 16. 16 times 5 is 80. Root 16 is 4. The 5 stays. Plus or minus 4 root 5 is the answer. All right. Keep going with the same idea. We're going to bring in some i's. We want a few practice problems with I. So square root both sides. Square root plus or minus x equals plus or minus negative root negative 50. Now, 50 is not a perfect square number. However, it is divisible by a perfect square number, and that's going to be 25. Break off the negative 1. Square root of 25 is 5. Square root of negative 1 is I. Root 2 is root 2, and that is the answer. First step is to subtract 21 from both sides. 13 minus 21 is negative 8. To get rid of the square, we square root, plus or minus, per the square root property. So x equals plus or minus root negative 8. 8 is not a perfect square number. However, 4 is, and 4 goes into 8 2 times. So we break apart the 8 into its negative part, its perfect square part, and then whatever's left over. Root 4 is 2, root negative 1 is I, root 2 is root 2. That would be the answer. First step, divide by 2, divide by 2. X squared is negative 125. Square root both sides, plus or minus. X equals plus or minus root negative 125. 125 is not a perfect square number. However, it is divisible by a perfect square number, that number being 25, and it goes in 5 times. 25 times 5 is 125. Plus or minus, root 25 is 5, root negative 1 is I, root 5 is itself. That's the solution. Okay, good. So we're just going to keep building off of that. These problems are gradually going to get longer and more involved. So stick around and practice as much as you want. Here we have 2x squared minus 5 equals 13. First step is going to be add 5. 2x squared equals 18. Divide by 2, divide by 2. X squared equals 9. Square root both sides. Square root property says plus or minus. Well, here we go. We got a perfect square. Square root of 9 is 3, so the answers are positive and negative 3, plus or minus 3. First step, subtract 28 from both sides. We have 3x squared equals, what is that, 72? Divide by 3. We have x squared equals, 72 divided by 3. What is that? 72 divided by 3. It's going to be 24. 24. Okay, all right, 24 is not a perfect square number, so we're going to have to simplify this, but let's go ahead and square root. Square root, use plus or minus. So x equals plus or minus root 24. Root 24, okay. Which perfect square number goes in to 24? That's going to be 4, and it goes in 6 times. So that's plus or minus 2 root 6. I don't know if you clicked around or if you're watching this video in order, but if you are confused about how I'm simplifying these radicals, right, that's what the first part of the video was about. So it's there for you if you need to go back and check it out again. First step, subtract 2. Second step, divide by 7. 16/7. All right, good. This is why we practice simplifying radicals with fractions. Here you're going to have to do it. 16 is not divisible by 7, so we're just going to push through with a square root next. And then you have x equals plus or minus 16 over 7 square root. Now, you can take the square root of 16, right? Root 16 is 4, so plus or minus 4 over root 7. Guess we should rationalize here the denominator. We would multiply by root 7 over 7, root 7 over root 7 over itself. Good. And this would equal plus or minus 4 root 7 over 7. And that would be the answer right there. Okay. As these problems progress, part of what's going to change is the order. For example, in this problem above, we added 5 to both sides, then divided by 2, then square rooted. In other words, we square rooted at the end. In this row of problems, our first move is going to be to square root, and that's the difference that the parentheses make. So, first thing here we want to do, we want to square root both sides. We want to square root both sides, plus or minus. So this gives us x plus 1, because the square and the square root cancel out, equals plus or minus 196. 196, that is a perfect square number. Square root of 196 is 14, so plus or minus 14. Good. Now we're really going to start to feel that this has 2 solutions. So this is not something we've had to do before, but I'm going to break off into 2 equations, and we're only going to do this when this number is a whole number. Or rather, I should say, when you are dealing with a perfect square number is where this is going to lead. Anyways, you have 2 possibilities, negative 14 and positive 14. We need to check for both. So from here, I will subtract 1 from both sides on both equations, and we have x equals negative 15 and x equals positive 13. So these are your 2 solutions for this equation. Immediately, the problem's already changing. We're not going to do that exact same thing here. Why? Because 50 is not a perfect square number, right? We don't have that convenience that we had in the last problem. First step is to square root both sides. Square root, put the plus or minus. So we have x minus 11 equals plus or minus root 50. 50 is not a perfect square number. However, it is divisible by a perfect square number, being 25. It's 25 times 2. X minus 11 equals plus or minus 5 root 2. Okay. So, yeah, in these 3 steps right here, we actually didn't do anything to progress in solving. All we did was simplify the root 50. We simplified the root 50. Now we're going to deal with this minus 11. What do you do with the minus 11? You add it to both sides. Add it to both sides. Good. Okay. You're going to have to start thinking about this. It takes a minute to get used to, but that's okay. that 5 is attached to a root 2. The 11 does not have a root 2, which in a sense means they are not like terms. So you cannot add the 5 and the 11. This is very literally going to be plus or minus 5 root 2 plus 11 because we added 11 to both sides. A little weird. Now, here's the way we traditionally write this. Write noun before the verb. We're going to put the whole number before the root number. So I'm actually going to rearrange this as 11 plus or minus, I don't like that penmanship, 11 plus or minus 5 root 2. And that is how we write this. So yes, your answers are going to have multiple parts, right? This is not a single number. This is it's not a complex number quite. We could call it a compound number. I don't know if that's the right word. Just made that up. Okay. And we're on to the next one now. So again, these problems are progressing. Notice the progression. We went from a perfect square number to a non-perfect square number. And then this time we're going to have a non-perfect square number, but it's going to be negative. So square root both sides. Square root plus or minus per the square root property. So we have x minus 19 equals plus or minus root 27. 27 is not a perfect square number. However, it is divisible by a perfect square number, being 9. We're going to break this up into its negative part, its perfect square part, and whatever's left over. At this point, we're still just simplifying the radical. Root 9 is 3, root negative 1 is I, and then the last 3 stays. Now we go ahead and finish by adding 19 to both sides. Adding 19 to both sides. So x equals, and we're going to write this as literally 19 plus 3i root 3. And that is a complex number because it has the I involved. So, good. It's not called a complex number because it's complex in the sense that it's difficult. It's a complex number in the sense that it has multiple parts. 2 parts, really. It has the real part and then the imaginary part. So your answers may look like that, and that is okay. You'll get used to it. It's definitely a lot different than your typical linear equation. Right. Don't be intimidated by the fractions. Not as bad as you think. Just takes a little bit of getting used to. If I want to move that 7/4 to the other side in a single shot, I can reciprocate it. So what I'm going to do here is I'm actually going to multiply both sides of the equation by 4/7. That 7/4 moves to the other side of the equation, reciprocates, becomes a 4/7. Now, when you're multiplying a whole number to a fraction, you're going to want to multiply up and divide down. I recommend doing the division first, just in case it works. So let's check. I'm using my calculator, not a problem. 112 divided by 7. 112 divided by 7 is 16. So this is 16. We still have to multiply by the 4. So again, this 16 right here, that came from 112 divided by 7. So check it. 112 divided by 7 is 16. We still have to multiply by the 4, though. The 4 doesn't go away. 16 times 4 is 64. A perfect square number. Fantastic. We're going to square root both sides, plus or minus. Square root of 64 is 8. So plus or minus 8. Here, our first move is going to be to add 10 to both sides. So we have 4/3. Actually, let me give us a little space here. 4/3 x squared equals 60. Okay, good. Let me give a little more explanation about this fraction situation here. If I want to get rid of a 4/3, I can multiply by its reciprocal, right? That's why we multiplied both sides by the reciprocal, because the 4s will cancel out and then the 3s will cancel out. That's why it works. x squared equals 60 times 3/4. So now your job now, you got to figure out what 60 times 3/4 is. You multiply up and you divide down. Now again, I recommend doing the division first if possible. So check, is 60 divisible by 4? Yes, yes it is. 60 divided by 4 is 15. We need to multiply that by 3, and that's 45. For the square root property, put the plus or minus, and so we have x equals plus or minus root 45. 45 can be broken into a 9 and a 5. Why do we like 9? Because 9 is a perfect square number, and the square root of 9 is 3. So plus or minus 3 root 5 would be the answer. To get rid of the square, we square root both sides. Plus or minus x minus 2/7 equals plus or minus root 13 over, I'm going to skip a step here and do 2 steps in one, root 49. That's 7. That's 7. 13 is a prime number. Can't simplify it. It's going to stay a root 13. All right, to get that minus 2/7 to the other side, we need to add it, right? Plus 2/7 plus 2/7. So again, this is going to very literally be 2/7 plus root 13 over 7. However, these problems will be designed to have common denominators ready to go for you. So we're going to write this as a single fraction of 2 plus root 13 all over 7, like that. Okay. Here we go. We got 9 more problems. Again, they're just progressing. The more you do, the better you'll get. First step here is to add 4 to both sides. Plus 4 plus 4. So we have x plus 5 squared equals 99. We need to square root both sides. I'm going to start just doing the problem straight through. So if I square root both sides, that's going to be plus or minus root 99. So x plus 5 equals, these parentheses here were not necessary. So x plus 5 equals 99. That's 9 times 11. So 3 root 11. And then I'm going to subtract 5 from both sides, which will give me negative 5 plus or minus 3 root 11. And that is the solution right there. Because everything's in the parentheses, the first thing we got to get rid of is that square. So we're going to square root both sides. Square root both sides right away. Square root plus or minus. So we have 2x minus 3 equals plus or minus root negative 15. Now, 15 is neither a perfect square number nor is it divisible by a perfect square number. That's just a long way of saying it's a prime number. Can't be simplified. However, that negative can pop out and become an I. So we'll write this as plus or minus I root 15. I will then add 3 to both sides. So 3 plus or minus I root 15. And then divide everything by 2. Divide the whole thing by 2. So this is just going to be one fraction unit all over a 2. All over a 2. Okay. First thing here is to add 7 to both sides. So we have 3x plus 5 squared equals 40. Then we're going to square root. 3x plus 5 equals plus or minus root 40. Root 40 is not a perfect square number, but it can be simplified. Pull apart the 40 into, what is that going to be, a 4 and a 10? So 2 root 10. Subtract 5 from both sides, negative 5 plus or minus 2 root 10. And then divide everything by 3. We have x equals negative 5 plus or minus 2 root 10 all over 3. And that would be the answer. All right, we got 6 left. Okay, the rest of this will not make sense to you if you are not familiar with perfect square trinomials. You need to know how to spot them and you need to know how to factor them. So at this point, I mean, you're welcome to hang out and try if you have no idea what I just said. Otherwise, my recommendation is that you go remind yourself what a perfect square trinomial is. You could find it on YouTube right where you're at. So this right here is a perfect square trinomial, meaning it can very easily be factored into x plus 2 squared equals 12. So really, we're just adding a new step at the beginning of these problems. The rest of it will be the same. That first step is to factor. This is a trinomial, but it is a perfect square trinomial, which allows us to write it as a binomial squared. And that's the important part here. Now that you have a binomial squared, you can use the square root property to get rid of that square. Square root both sides, plus or minus. So we have x plus 2 equals plus or minus root 12. Simplify root 12 into 2 root 3, and then subtract 2 to both sides. From both sides. And that is the answer. This right here is a perfect square trinomial. It can be factored into 2x minus 3 squared equals 225. Nice, 225. That's a perfect square number. So we're going to take the square root of both sides. Square root property, right? It says plus or minus. So we have 2x minus 3 equals square root of 225. That's 15, right? Plus or minus 15. Okay, cool. So again, we haven't seen this. This is the second time we're going to be able to do what we're about to do. We've done it once, and that is actually split off and find our two rational. I believe they're going to be rational solutions. If not whole, they might even be whole. That'll be nice. So since we can, we're going to solve out 2x minus 3 equals negative 15 and 2x minus 3 equals positive 15. So both of these equations require you to add 3 to both sides, add 3 to both sides, and then divide by 2, giving us negative 6 and 9. Again, it's most of the time, expect your answers to more often look like something like this. But in those nice cases where you're dealing with a perfect square number, you should be able to actually work out the two solutions separately. So that's nice. You know, we'll appreciate it when it happens. All right, as promised, this is a perfect square trinomial. It can be factored to 3x plus 5 squared equals negative 52. So back to a non-perfect square number, and it's going to be negative, which means we will have i's in our solution. Square root both sides, plus or minus. So we have 3x plus 5 equals plus or minus root negative 52. Root negative 52, you might have to think about that. That's 4 times 13. 52 is 4 times 13. We like 4 because it's a perfect square number. So we're going to bring out the root 4 is 2. I, because the negative, that 13 will stay. Subtract 5 from both sides. Divide both sides by 3. That's the answer. Okay, the last ones here are challenge problems, but I do want you to get comfortable with fractions because, hey, they're not going away. So, however, they are still perfect square trinomials. You might have to think on your own time why these factor the way they do, but I'm just here to tell you that first piece factors to x plus a half squared equals 3/4. I square root both sides, and that gives me plus or minus root 3 over root 4 is 2. I can square root 2. And then I subtract 1/2 from both sides, making it -1 plus or minus root 3 over 2. So again, I am going straight towards the answers here. You might have to think about these. Second one, this is a perfect square trinomial that'll factor to x minus 1/3 squared equals 4/9. I square root both sides, which gives me x minus 1/3 equals, plus or minus 2/3, right? Root 4 is 2, root 9 is 3. That's nice. And then I'm going to add 1/3 to both sides, which is 1 plus or minus 2 over 3. Now, we don't have any roots here. We can work this out, right? We can work this out. We have two possibilities here. We have x equals 1 minus 2 over 3, which is, what's 1 minus 2? 1 minus 2 is -1/3, is one solution. And then we also have x equals 1 plus 2 over 3, which is 3 over 3, which is 1. So we have two rational solutions here, -1/3 and 1. And again, that is because this number right here was, well, 4/9 itself. I don't know if you'd call 4/9 a perfect square number, but it's a fraction in which both the numerator and the denominator were perfect square numbers. That gave us a nice clean 2/3. Last one here. Let's see, this is going to give us x plus 3/4 squared equals -200 over 16. If I square root both sides, I have x plus 3/4 equals plus or minus root -200. 16 is a perfect square. Root 16 is 4. I'm going to simplify that numerator. So 200, what is that? That's 100 times 2. 100 is a perfect square number. So we can pull out 10. Square root of 100 is 10. I for the negative, and then the 2 stays over 4. And then I'm going to subtract 3/4 from both sides, giving me a final answer of -3, because we subtract, plus or minus 10I root 2 over 4. There you go. Good. Don't stress about these last ones. If you're in high school or in like a college algebra class, a freshman college algebra class, these last problems are more advanced than you need to know, but they're there if you enjoy them. So I'll leave this PDF in the description and for you if you want to check your answers. So very good. Thanks for sticking around and watching this lesson on the square root property. Please like and subscribe and keep an eye out for more lessons in the future.